The final level of systems of equations is when one or both of our systems have a fraction, which is really common on the SAT. And you guys have to decide if you're going to use substitution or elimination as the best strategy to solve it by hand, or you can always, resort to graphing if you know how to use that technology, especially on the SAT. So today's goal, guys, is to help you guys tackle systems of equations that have fractions and have you guys decide how to get to the solution. Then tomorrow you will apply this to a handful of SAT questions. So when we see this is what I mean by a system of equations with fractions. Obviously, there are fractions. We have two equations. And before we solve, we need to try to deal with the fractions, and then we'll choose a strategy, substitution or elimination, to solve it, okay? So go ahead and write down those two equations on a piece of paper so we can go through and get rid of the fractions to make it look a little more normal like the last couple weeks. So the easiest way to get rid of fractions is to pick a multiplier, where you're gonna multiply the entire equation, all three items, by some number, and after you're done multiplying, if you picked the correct multiplier, the fraction will be gone. And we're gonna treat these as two separate problems. So we're probably going to use a different multiplier since these have different numbers in the bottoms of the fractions. If you have a problem like this, where you only have one fraction, you can literally just take whatever the denominator is of that fraction. In this case, it's over 3, and we can make 3 the multiplier. And I like to put the little 3 above like this to show that I'm about to do 3 times negative x, 3 times negative 2/3 y, and 3 times 3. Since there was only one fraction, I took that denominator, and that's the number I chose for multiplying. So now 3 times negative x is negative 3x. Now over here, guys, when we do this, whenever we multiply, you're going to take your multiplier times the top number, then divide it by that bottom one. So in this case, 3 times negative 2 is negative 6, divided by 3 is negative 2y. Equals 3 times 3 is 9. So now we see, boom, it's gone. Remember, guys, when we multiply with that fraction, you're going to take the multiplier times the numerator, then divide it by that denominator. 3 times 2 is 6, divided by 3 is 2, and that negative came on down with it. Now over here, when you have two different numbers underneath, whatever multiplier you choose needs to be divisible by both of these numbers. So if you chose chose 3 to put up there, 3 divided by 6 gives you 0.5, a decimal, so we don't want to use it. Whatever multiplier we get, this is your mental check, needs to be divisible by every different denominator. So since 3 divided by 6 gave us a decimal, it didn't work. But if we use 6, 6 divided by 6 is 1, 6 divided by 6 is 1, 6 divided by 3 is 2. Since 6 is divisible by both 6 and 3, we can use 6 as that multiplier up there. 6 times 1 is 6, divided by 6 is 1x. 6 times 1 is 6, divided by 6 is negative 1y. 6 times 4 is 24, divided by 3 will be 8, and don't lose track of your negative up there. And voila. Now we have our two equations, and they don't have fractions anymore. So I'm going to restack them up so it looks like our normal systems of equations. And now that we've picked a multiplier and multiplied it out, this looks just like what we've been doing. So now I want you guys to try to solve this on your own, choosing substitution or elimination, whichever one you prefer. And then you guys can check your answer with the next video, where I will walk through this step by step. But I want you guys to try it on your own first.